This program, FIRFILTPZ, allows you to visualize the frequency response magnitude and the pole zero plot of FIR filters designed using linear phase window-based methods. The left panel shows the magnitude of the frequency response of the filter on a linear scale. Clicking the log scale button changes the display to dB. The lower limit of the magnitude can be adjusted with this control here. The program starts with a rectangular window filter of length 25 and a corner frequency of pi/2. The top right control here allows you to change the filter type, for example, Kaiser. Filters such as the Kaiser filter have additional parameters that can be specified with this slider or the edit box where appropriate. The top slider and the edit box here adjust the corner frequency of the filter, which can also be adjusted by pulling on this little green triangle. The standard types of filters, low pass, high pass, band pass, and band stop filters can be selected with this control here. If you select a band pass or band stop filter, then there are going to be a couple of sliders for the center frequency of the filter and the bandwidth. You can adjust the center frequency of the filter with the center triangle, and you can adjust the bandwidth with either of the outer triangles. If you click inside the magnitude plot, a cursor shows up giving the magnitude and the frequency, and there's a little green dot that goes around the unit circle at the appropriate frequency. You can select a sound to filter from the menu. In this case we have
She sells seashells.
She sells seashells, and you can then filter it.
She sells seashells.
Once a sound has been selected, small red numbers appear below the frequency axis that scale the filter's critical frequencies by the sample rate and express them in hertz. Finally, you can save the parameters of any filter that you've created into a file here. This program is one of a suite of programs that I have developed to explain DSP concepts to my students during lectures. There are now well over 24 programs covering many aspects of the material in the book, including complex exponentials and sinusoids, convolution, the DTFT, pole zero plots and their relation to frequency and impulse response, A to D and D to A conversion, including upsampling, downsampling, resampling, and aliasing, the design of many types of FIR filters and their application to the filtering of speech and other signals, the design of IIR filters, circular shift and convolution using the DFT, the discrete cosine transform, and the short-time Fourier transform. A selection of these programs is being made available to instructors who are currently adopting the book in their classrooms. For further information, please visit cambridge.org/Holton.